Here we'll take a look at some additional Venn diagram examples, starting with number 1. A college food court surveyed a group of students to see how many of them drink coffee and how many drink tea. And the Venn diagram summarizes here. So inside of our rectangle, this would be people in our sample space. So we've got 12 students plus 8 plus 2 plus 3. So that will answer part A. How many students were surveyed? I'm going to actually write there N. Again, we just think of as number of people, students in this case, in our sample. So adding up all the people inside the rectangle of the Venn diagram, and that will be 25 students. So 25 students in total. And then how many drink coffee? So everybody that's part of the coffee circle, and I'm just going to circle it here in red. So 12 students plus 8, and I'll just write outside my circle, then that would be a total of 20 people inside the coffee circle. So there's a reason I'm going to write down 12 plus 8 over here, but that is again 20. Okay, and then how many drink tea? And I'm just going to switch color here. Here's the people inside the tea circle. And so that would just be those 8 people plus 2 more. So we've got 10 students that indicate they drink tea. And I'm going to write down where I got that number. 8 plus 2 inside the tea circle is 10. All right. So sometimes it seems like something is wrong. If 20 people drink coffee and 10 drink tea, that adds up to 30 people, but there's only 25 people in the study. And this is what we talked about earlier. When we have an overlap, the 20 includes those 8 people, but then the 10 also includes those same 8 people. So over in my expressions here, I'm just going to highlight there, the 8 people counted towards the 20, the 8 people counted also towards the 10. So the people that are in both groups and are those 8 people. So and remember is intersection. So people that have or meet both criteria. So intersection. And then let me do or using 2 different methods. All right, so or is union. So you join the 2 groups of people. So you take everybody that drinks coffee, there's 20 people, plus take everybody that drinks tea, there's 10 people. But if you add those 2 numbers up, you'll have counted 8 people twice. So to get us to the correct answer, we do have to subtract 8. So we're not double counting those 8 students. And that will give us, so it would have been 30, subtracting the 8 that's double counted. We've got 22 students that either drink coffee or they drink tea, or they happen to drink both. And then the other way you can think about union is it's everybody that is inside these circles. So if you just add up people and don't double count anybody, you can literally just add up the 12 people plus the 8 people plus the 2 people inside those circles, and that also gives you 22. So 2 different ways to think about it. And we'll try another. All right, number 2. A tile is selected from 7 tiles, each labeled with a different letter from the first 7 letters of the alphabet. And we'll pick a letter at random and consider these 2 events. All right, so first what I want to do is list the sample space, and you also hear it referred to as the universe. So every outcome that would be possible, and we have 7 tiles, A, B, C, D, E, F, G. So 7 tiles labeled with the first 7 letters of the alphabet. 1, 2, 3, 4, 5, 6, 7. Okay, so event X is that the letter comes before D. So I'm just going to write the letters before D. So event X would be A, B, or C. And then event Y is the letter is found in the word cage, and I'm just writing it over because I want to. And then part B says, let's find the outcomes in the event X and Y. So letters that are common to both X and Y. And I'll be putting those here in that intersection. So the letters that they share, I'm just going to highlight them. So those both of those events contain an A. Both of those events contain a C. So the A and the C are part of event X, and they're also part of event Y. So that is A and C. All right, or again is union. So it would be every letter that's part of X along with every letter that's part of event Y. So we would take all the letters in event X, A, B, C, along with all the letters in event Y. So we already listed the C and the A, so all that's left here to list would be the G and the E. So I'm going to fill out my Venn diagram again. So for event X, we've got the A and the C. We still need a B. So B is part of event X. It's just not part of event Y. And so just color coding again. So there's my letters in event X, and then my letters in event Y. So I already have inside of Y, I already have the A and the C. I'm just missing the G and the E. And the rectangle represents the sample space. So I think I'm missing some of the letters still. So we've got A, B, C. I'm just going to cross out over here. I've got the A, the B, and the C. I've got the G and the E. So the letters D and F are part of neither one of these events. So D and F would be outside those circles. And now we've got our sample space complete. So you just have to remember your sample space is everything that could possibly happen, just for emphasis here, writing them again. Okay, the complement of event X. So notation-wise, when we have a complement, we put a bar over it. So I know that looks like the sample mean, but we just have to understand the context of the question. So we're not talking about means, we're talking about events. So, oops, sorry about that. So event X. So that notation is one way to write it, and that's the one I generally use. Some books you'll see X with a little c for the complement. And the way we read this is everything that's not in X. So all letters on our tiles that are not part of event X. So event X was ABC, so the complement would be everything not there. So it'd be GE and DF. And it doesn't matter, they don't have to be alphabetical, you just have to list them. So GEDF is everything not in X. Okay, one more. We have a deck of cards numbered 1 through 8. Some are gray, some are white. And the gray ones are 1, 4, 6, 8. That's my event A. And my event B is that it's an even numbered card. So I'm going to just rewrite, there's event A. And then even number cards would be 2, 4, 6, 8. So the sample space, so if you're going to pick one of these cards, you could get any one of those 8. And then that symbol again is intersection. So the cards or the numbers that are common to both. So intersection versus the next symbol is union. For intersection, we say and. For union, we say or. So let's do intersection. So we're looking for outcomes common to both groups. So I'll just highlight them here. They share a 4. They share a 6. They share an 8. So I'm just going to put this over here. So the answer here is they share a 4, a 6, and an 8. So those numbers are common to both sets. So the 4, the 6, and the 8 are part of both event A and B. All right, so continuing this problem, we have 4, 6, and 8 in the intersection. And then I'm going to complete the Venn diagram before I continue with union here. So event A, we're still missing a 1. So 1 is part of event A. So now we've got, oops, sorry, event A, 1, 4, 6, 8, we got that. And then event B should have 2, 4, 6, 8. So we're still missing the 2. So that's over there. And then our sample space, let's see if we're missing any numbers. So 1, 2, I'm missing 3. So that's outside both of those events. And then I've got the 4, I'm missing the 5, I've got the 6, I'm missing the 7, and then I have the 8. So now we have our Venn diagram complete. And then we'll do union. So union means the joining of the sets. So you're going to take everything in A. So again, the order you write them in doesn't matter, but I'm just going to do A first, 1, 4, 6, 8. And then to finish out, I also would need the 2. So union is everything inside of the circles. And it helps, if it helps to think about shading again, union means everything inside the circles. So you're counting things, whether they're in one group or the other group, or possibly both. Okay, and then this notation again, event A, complement. So the A with the line over it is A complement. And that's red, not A. So I'll add the word in, not in A, the complement of A, everything not in A. So everything outside of my A circle. You can also just look here, everything that's not one of those numbers. And that would be 2, 3, 5, 7. So 2, 3, 5, 7. And that should be sort of a good summary of various Venn diagrams.